Welcome back to Aurora Tech Channel. Today, I will review the WeCreat Lumos, a 10-watt diode and 3-watt infrared dual laser machine. In the current market, there have already been a few similar models for a while, some of which I've tested, like the Xtool F1 and LaserPecker LP4. All three machines use a 10-watt diode laser, but the Lumos features a 3-watt IR laser compared to the 2-watt used by its competitors. In terms of price, the LaserPecker LP4 costs around $1,400, the Xtool F1 is about $1,100, and this WeCreat Lumos is priced around $1,100 to $1,250, depending on when you buy it. Let's take a look at what it offers. Instead of using the traditional motion system, where the laser head moves back and forth on a gantry, the Lumos uses a galvanometer system, or in plain English, two mirrors that rapidly reflect the laser beam. This allows it to move at ultra-high speeds of up to 4,000 millimeters per second, or 240,000 millimeters per minute, which is more than 10 times faster than a regular laser engraver. The 10-watt diode laser can work on materials like wood, acrylic, fabric, and leather. However, like all diode lasers, it's not suitable for reflective metals or certain plastics, and that's where the 3-watt infrared laser comes in. The standard working area is 116 by 116 millimeters, and with the optional extension slider, you can expand it 4 times to 420 by 116 millimeters. There are also other accessories available, such as a rotary roller that works with the extension, and a portable cover that lets you use the device handheld to engrave on larger or vertical surfaces like walls. It also has a built-in camera for material positioning and a contour outline preview that helps align non-rectangular designs. The Lumos runs on WeCreat's own software, similar to Xtool Creative Space, supporting both USB and Wi-Fi connections. The software includes AI features and a library of ready-to-use projects, which you can access for free for 6 months. It supports autofocus in the software, as well as both manual and automatic focusing using the knob and button on the machine. I would like to thank WeCreat for sending us this machine and for sponsoring today's video. As always, even though this is a sponsored review, we won't hold back from pointing out any cons or issues found during testing. This is because I believe this helps buyers have a reasonable expectation before deciding whether to buy this machine or not, and it also lets the manufacturer know what they can improve on in future updates. With that said, let's get started. The machine came in a compact box. On top, there is the user manual and some sample materials. Underneath are the machine and the power supply. Other accessories like the base plate, cutting panel, and ducting are packed inside the machine. There are also some tools and cables. The laser head can be removed easily, as it's connected by connectors instead of cables and secured with a thumb screw. We don't need to install anything, just plug in the power, the USB cable for the first-time setup, and the ducting. I'll just connect it to my bad-looking but functional ducting to exhaust the smoke outside. After removing the lens cap, we can power it on. You can download the software from their official website, but since I already own another WeCreat machine, I already have it installed. Once the machine is powered on and connected via USB, it detects the machine and prompts a firmware update dialog. I'll let it update. After a while, it requires powering off the machine and turning it back on. I'll then set up the Wi-Fi so I can get rid of the USB cable. As you can see, the machine is currently connected through USB. I'll go to Settings, select Wi-Fi settings, choose my SSID, and enter the password. It seems to support only 2.4 GHz networks. Once it's connected, you can see the connection change from USB to the IP address of the machine. Okay. I'll start with a simple test to make sure everything is working. I'll place a Hello Kitty image, select 3mm MDF as the material, and let the engraving parameters set automatically. I'll also create an offset cut to cut this image out. It seems that using 100% power at 2 millimeters per second is way too much for this thin MDF. But let's see what happens. I'll use the autofocus feature to set the focal length. The camera also refreshes with the updated image of the MDF piece I placed inside the machine. I'll move it to the left corner. Since we already have a camera, we normally don't need a preview frame, but I'll still let it draw one. Everything looks good, and I'll start the job. The estimated time is 1 minute 3 seconds. The engraving took about 9.5 seconds. As expected, using 100% power at 2 millimeters per second is way too much, but I'll still let it finish. The job took 36 seconds, so the estimated time of 1 minute 3 seconds from the software is not accurate. The engraving parameters are fine, but the cutting parameters are definitely off. I'll move the image to the center and refresh the preview. I'll increase the speed from 2 to 20 millimeters per second. It would be better to run 2 passes, as this type of laser doesn't have air assist. It's better to move the laser dot faster with multiple passes. This time, the estimated time is 19 seconds. The estimated 19 seconds is spot on. The cutting is much better at a higher speed, but it didn't cut through. I'll make another attempt with 80% power, 20 millimeters per second, and 3 passes. The estimated time is 24 seconds, and this estimate is also pretty close to the actual job time. The wood cut through completely. Here are the results with different parameters. Sometimes you need to play around with speed and power, but the default cutting parameters for 3mm MDF in the software are way off. I'm happy with the last one, using 80% power at 20 millimeters per second with 3 passes. Next, I'll try engraving an aluminum-coated business card using the blue laser. I found a black-coated aluminum preset in the library, so I'll use the default parameters. It's set to 100% power and 10 millimeters per second, which might be a bit too much, but diode lasers on coated aluminum usually don't perform as well as IR lasers, so I'll just let it run. I'll do a preview frame. At first, I only saw a rectangular frame, which isn't ideal for aligning round objects, but it works fine for this business card. Once I click the Start button, I noticed an option for outer contour framing. It looks much better. The estimated time is 3 minutes 20 seconds. It finished in about 2 minutes 57 seconds, 23 seconds faster than estimated. The result looks like a typical diode laser engraving on coated aluminum, not too bad from a distance. If the parameters are more dialed in, the result may improve slightly, but it won't make a huge difference. However, when zoomed in, you can see that it burns off the coating using high heat. Now, let's try the IR laser, which I expect to produce much better results on coated aluminum. Under the red laser material list, I can't find coated aluminum, so I'll select acrylic or any material and adjust the parameters manually. For power, I'll keep it at 100%, and for speed, 500 millimeters per second. I can generally get good results using a 2-watt IR laser like the X-Tool F1 on this type of card, so since this one has a 3-watt laser, it should work well too. For the outline, I should also set it to 500 millimeters per second, but I'll keep it at 10 millimeters per second to see if slower speeds make a difference on the outline marks. The estimated time is 24 seconds, but most of that should be spent on the slow 10 millimeters per second outline. The logo itself should only take a few seconds. The 10 millimeters per second outline is quite slow, but it speeds up to 500 millimeters per second once the outline is done. The outline took about 16 seconds, and the logo took about 4.5 seconds. As you can see, the IR laser produces much better results on coated aluminum. The lines are sharp, and even when zoomed in, they look clean. The outline at 10 millimeters per second isn't as good as the rest of the logo engraved at 500 millimeters per second. Compared with the close-up shot of the diode laser engraving, the difference is huge. Coated aluminum cards are one of my favorite materials for IR lasers. The result looks beautiful. I'll now try engraving on some different metals, starting with a pair of scissors that has a stainless steel blade. I'll reload the image and use the camera to position the text. I can find stainless steel in the material list, so I'll just use the default parameters. I'll place some simple text and draw a contour outline preview. The estimated engraving time is 2 minutes and 4 seconds. Let's start the job. This time, the job took 1 minute and 53 seconds, which is quite close to the estimate. The result looks really good. Even when zooming in, the text is clear and sharp. Next, I'll engrave a logo on another stainless steel spatula using the same default parameters from the software. I'll try to stick to the default settings as much as possible, and if I need to make any changes, I'll mention them. This vector graphic engraving was also pretty fast. It finished in 2 minutes and 18 seconds. This spatula is one of my regularly used 3D printer tools, so the surface already has some wear, but the engraving still turned out very clean. Then, I'll try a piece of 6061 raw aluminum. I'll engrave the same vector logo again, but this time in fill mode, still using the default parameters. It's strange. After completing the fill, it also engraved the outline, as if line mode was selected. That added about 10 extra seconds, with the total job finishing in 2 minutes and 29 seconds. The result still looks good, with or without that extra outline pass. Next, I'll engrave the same logo on a brass coin using fill mode. The laser scans line by line, just like with the aluminum piece, but the brass parameters are much slower. Once again, it still engraves the outline after the fill is done. That added another 2 minutes and 25 seconds, making the total job time 16 minutes and 5 seconds. Engraving on brass takes longer, but the contrast looks noticeably better than on raw aluminum. I think the result could look even cleaner without the extra outline pass, since it makes the fine text a bit less sharp. Up next, I'll try some color engraving on stainless steel. I'll run a test pattern from the software to see what colors the machine can produce on this piece of stainless steel by changing the focal length, power, and speed. It looks like we can get different shades of blue, green, yellow, red, and gray. Then, I'll try to use some of these colors for a Hello Kitty picture. I'll refer to the test results and input the matching settings. Engraving the dark outlines is pretty slow, since it requires just 10 millimeters per second to produce that color. The other colors are a bit faster, but still, this small tag took just under 15 minutes to complete. Under certain lighting, you can see the color differences. It's not super vibrant, but it's still nicer than using only light and dark shades. After that, I'll engrave a photo on a coated aluminum card. Since the card is black, I have to invert the photo to negative. Just like in one of my first tests on the same type of material, I couldn't find the corresponding parameters in the software. I started with the aluminum profile, but the dot duration was set to 230, which was too strong for this coated surface. I stopped the job, restarted it, and set the dot duration to 100. I also set the DPI to 600 to see what kind of resolution it can produce. It's still the same card, so you'll notice a few higher contrast lines at the top from the previous stop job, when the dot duration was set too high at 230. It took about 11 minutes to engrave this credit card size photo, and the result is stunning. This photo was taken a few years ago, and you can clearly see some old generation machines in the background, like the Ender 3, CR10S Pro, Prusa Mark III, and my first 3018 CNC. Next, I'll engrave the same logo on black acrylic and cut it out. Both the Diode and IR lasers can engrave on acrylic, but the 3-watt IR isn't suitable for cutting. I'll use the Diode laser for both engraving and cutting in this test. The engraving took 1 minute and 10 seconds, and the unexpected extra outline added about 4.5 seconds. Cutting took 45 seconds, bringing the total job time to around 2 minutes. The engraving looks great, and the cutting is decent from a distance, but when you look closely, the edges appear rough, which is normal for a diode laser. If you want a mirror smooth edge, you'll need a CO2 laser to cut acrylic. I'll also try clear acrylic, but since neither laser can engrave on transparent materials, I placed a piece of raw aluminum underneath to protect the machine. The engraving you see is actually on the aluminum, not on the clear acrylic itself. Next, I'll try some 3D printed parts. I just made 2 wrenches for my dad's new toy, a custom 1911, where the fitting is super tight and not easy to disassemble. I'll engrave some text on one wrench printed with polycarbonate carbon fiber. This kind of engraving is quick, it only takes about 10 seconds. The result looks okay, though a bit light on the carbon fiber surface. I'll run the same job again on another wrench printed with PETG, and this one looks better. The text appears clearer and more visible. Then I'll grab one of my camera lights and test how engraving looks on this ABS housing. It only takes 4 seconds, and engraving on a smooth ABS surface looks much better. The text is sharp and clear. When zooming in really close, it actually looks even cleaner than the factory engraving. Now I'll take a closer look at the software's smart features. One function I really like is the ability to use the camera to transfer something from the real world onto your workpiece. For example, if a customer wants to engrave their handwriting, you can simply use the built-in camera to capture and extract it. Select the Extract Image tool and crop out the part you want. After that, I'll remove the background using the image processing tool. Just adjust the values until you get the desired result. Since it's still an image, I'll use the Sketch tool to trace the lines. Depending on your handwriting, you might need to fine-tune those numbers. Now it's converted into a vector graphic. From here, you can follow your normal workflow and combine it with your project. It took less than a minute to engrave this tree and the handwriting onto a plywood tile, and compared to the original writing on paper, the result looks amazing. There's also a batch production mode. At first, I thought it worked like Xtools software, where you can randomly place the objects and the software automatically detects them and applies the design. But it turns out that's not the case. Here, you have to manually measure the material thickness, set up a grid, and input the number of rows, columns, and spacing. It requires quite a bit of manual setup, which I don't really like. If you're engraving a lot of rectangular pieces, it might be worth the time, but for just a few items, I'd rather spend 20 seconds positioning them manually. Engraving all 3 pieces took 3 minutes and 17 seconds. You can see one of them looks lighter, but I won't blame the machine this time. I was using the wrong side of the plywood. Some plywood made for engraving may have a thin layer of baking soda water or another coating applied to enhance contrast, and you can see that the color of the wood is lighter on the last one. I will then test some optional accessories available for this machine, starting with the slide extension. There are alignment pins that can be mounted on the base of the machine, which align perfectly with the holes on the bottom of the extension. It's basically like a 3D printer bed that slides from left to right, extending your engraving area by 4 times to 420 millimeters. I'll engrave this long PCB-style sign. The image was actually generated using their AI tool. I made one first, but wasn't quite happy with the result, so I kept adjusting the prompt just like you would with any other AI image generator. I'll engrave this image onto a 300mm long piece of plywood and then cut it out. The default engraving speed for plywood is 158mm per second, but I increased it to 250mm per second. Still, after 5 minutes, only about 15% of the engraving was done, so I expected it to take a while. The job finally finished in about 46 minutes. The engraving result is quite good. I can see some depth when zooming in. For cutting, the shorter sides came out perfectly straight, but the longer sides were cut at a slight angle since the laser is fixed in the center. The top cuts are clean because the exhaust fan pulls the smoke upward, leaving the charred residue on the remaining stock. However, the bottom side is charred while the remaining stock is clean. The next accessory I tested is the Rotary roller. Unlike regular rollers, this one can actually work with the slide extension. You can remove the bed from the extension and mount the roller directly on it. This setup lets you engrave longer objects as the slider moves the roller back and forth, giving you the same 420mm engraving area. For this test, I added some text and a logo onto a baseball bat. The roller's speed is limited to 250mm per second, which isn't very fast, but I maxed it out to see how long the job would take. As you can see, the roller turns quite slowly, and combined with the one-way engraving system, I wasn't expecting this to be quick. It finally finished after 2 hours and 49 minutes. The engraving result looks great, but it's really slow. If I were to engrave the entire bat, it would probably take 4 to 5 hours. The final accessory is the handheld protective cover. You can remove the laser head and snap it onto this magnetic cover, which allows you to engrave larger objects that don't fit inside the machine, like a tabletop. Of course, I didn't want to engrave my workbench, so I placed a piece of scrap plywood instead to show how it works. I reduced the power to 50% since there's no way to connect ducting to vent the smoke, and I didn't want to fill the garage with it. The result looks similar to my previous plywood test, except now you can take it anywhere as long as the power cable can reach. I also tried engraving on a vertical surface, but this setup is quite heavy, around 2.7 kilograms or almost 6 pounds, and I couldn't hold it steady for long. Using the same settings, the text on this Home Depot plywood came out lighter than before, so I ran a second pass. You can see my hands weren't steady enough to keep it consistent, so the result isn't as clean as the previous test. Overall, the handheld mode works, but the weight definitely makes it a challenge for someone like me to use for longer engravings. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The IR laser is fast. For metal engraving, it's actually quicker than the X-Tool F1 and LaserPecker 4, mainly because it uses a 3-watt IR module instead of the 2-watt found on most competitors. As for the diode laser, it's definitely faster than traditional engravers, but since it's still a 10-watt diode, the speed difference isn't huge. The single-direction engraving also contributes to slower overall performance, which I'll discuss more in the cons section. 2. The built-in camera is really handy for positioning materials. It's not quite as precise as the outline preview frame, which can achieve pinpoint accuracy, but it's great if you just want to place multiple items on the work area and make full use of the space. Another nice feature is that you can capture something like your own handwriting and extract the outline to add it directly to your project. 3. The autofocus works really well. I did most of my tests using it without any issues. The only exceptions were mirror-finished stainless steel and dark acrylic, which don't seem to work as well with the autofocus system. 4. The engraving quality is really impressive. Photos engraved with this machine look almost like actual printed images. At 600 dpi, I was able to engrave this credit card-sized photo in about 11 minutes. 5. It works on almost anything. The IR laser isn't just great for metal. When engraving plastics or 3D printed parts, it doesn't melt the surface like a diode laser can. The manufacturer claims it can engrave on over 300 materials, and honestly, that's not far off. It can handle nearly everything except transparent materials. 6. The stronger 3 watts IR laser also lets it do some color engraving on stainless steel. The colors aren't as vibrant as what you get from a $6,000 100-watt MOPA fiber laser, but they're definitely better than what a 2-watt IR can produce, which is usually limited to just darker and lighter shades. Now for the cons. 1. The biggest drawback of this machine is that it only engraves in one direction. Unlike other models that fire both ways, it only engraves from left to right, which slows down the job. Still, the 3 watts IR laser's higher energy output helps offset that limitation in many cases. Its stronger beam engages the surface more effectively, requiring fewer passes or shorter dot durations, especially on metal. Even with single-direction engraving, it still outperforms a 2-watt laser in some situations. That said, there's no reason it shouldn't support bidirectional engraving, and I hope WeCreat addresses this in a future software or firmware update. 2. The software is better than average and very usable. I was able to complete all my tests using only their own program. That said, it still lacks some refinements compared to Xtool's software. For example, the material library isn't complete. I couldn't find coated aluminum card under the IR laser section, even though that material actually works better with IR than with a diode laser. Most of the material parameters are spot on, but a few aren't accurate, such as the 3mm MDF diode laser cutting in my earlier test. When users follow the default software settings but don't get the expected results, it can be frustrating. I also noticed some odd behavior. An extra outline gets engraved even when I only select the fill mode. I'm not sure if that's by design or a bug, but if it's intentional, it shouldn't be, and if it's a bug, it needs to be fixed. 3. This machine markets itself toward business users, and I'd imagine those users are making the same parts over and over again to sell, chasing those nice-looking profit numbers on the product page. I'm not sure how realistic those numbers are, but either way, a solid batch production feature is essential. Unfortunately, the one in their software isn't great. It needs way too much input from the user. You have to lay everything out in a perfect grid, count the rows and columns, and even measure the gaps between them. I'd much prefer it to work like Xtool's software, where you can just drop the materials randomly and it automatically detects and aligns everything for you. Xtool's system isn't perfect either. It still has some minor alignment issues, but it's definitely way better than this. In conclusion, the WeCreat Lumos is a solid machine. The hardware is top-notch, with a build quality that's on par with Xtool, and it comes fully assembled, making it very beginner-friendly. Overall, the performance is better than average. With the stock configuration, it works a lot like the Xtool F1 on your desktop. When paired with the optional protective cone, it can also function like the LaserPecker LP4, offering portability and the ability to engrave on larger objects and vertical surfaces. This is the second machine I've tested from WeCreat, following the vision, which was also pretty innovative. It's clear that WeCreat is a company with strong potential. Their software is better than average, but still not quite at the same level as their hardware, leaving room for improvement. It's not perfect, but for anyone looking for a dual laser setup with both diode and IR lasers, the Lumos is a good option. At nearly the same price as its competitors, the 3-watt IR and 10-watt diode combination makes it pretty competitive. At the end of the day, a 3-watt IR laser is certainly better than a 2-watt. If you're interested, I included a link to the machine in the description below. Don't forget to also check out auroratechchannel.com, where you can track prices of popular 3D printers, laser engravers, and CNC machines to find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.